Hey, you're listening to Dr. B, and let's have a look at count 'em, five states of matter. Going from cold to hot, a substance may be in any of these five phases. Now, two of them are a little weird. This one here, it is definitely non-classical, but it shows up sometimes, so we might as well learn it. And this one shows up now in most textbooks, but it also is a little bit non-classical, which means we're cheating just a little bit. So let's have a look at each one. We're going from cold to hot. If you go cold enough, substances exist in the solid phase, right down to helium, you name it. If you heat them up a little bit, now typically they will go to a liquid. I mean 99% of the time. But once in a while you get substances which under a microscope look a little bit like this. These are liquid crystals. They are defined as highly ordered liquids. Continue to heat things and you get the more common phase, which is liquids. So let's not take that too far. Just be aware that these exist once in a great while. They're known as liquid crystals. The most common next phase, however, is a liquid. Heat it up a little bit, you're likely to get a gas. And if you go beyond that, it's not necessarily heating it, it's ionizing it, adding or taking away electrons, and that turns it into a plasma. Those are five different states of matter. Will they fill the bottom of a container perfectly? A solid? No, it will not. They can have air voids, things like that. A liquid crystal? Yes, it would, but as it flows into that container, it would be forming a highly ordered system analogous to a solid. A liquid will definitely fill up the bottom of the container, absolutely. But as it does so, those molecules are free to pass by one another and exhibit some intermolecular forces as they do so. Gases, well, even a few molecules are just going to bounce around, and so they, yes, will fill the bottom as well as the top of the container completely. And plasmas we don't really need to consider since they are ionized gases, but they'll behave like gases would, bouncing around. Well, I wrote no. They only fill the. Will they fill it completely? Lightning. Oh, you know, I'm not sure you can get lightning in a bottle, so maybe we just don't really need to go there. Will it fill all of the container? No, you'll get air voids for your salad. I mean, if it was perfectly placed in there, it would. Would a liquid crystal fill all the container? Yes, it would. No, not if you don't have enough of it. That means like regardless of the amount. So a liquid crystal, no, not if you don't have enough. A liquid, no, not if you don't have enough. A gas, it doesn't matter how much. Yes, that's the big point we want to make there. Plasmas are weird. We're not going to go there. Are they compressible? Solids, no, they're just going to crack and break. A liquid crystal, like a normal liquid, no, you cannot compress this, and it's a nice thing to observe. They're non-compressible. Gases compress a lot. They can compress 90% or more if you press down on them. Plasma, once again, we don't really care. So this is a quick look at five states of matter and a little bit about how they behave. Two of these states are non-classical.